Okay, this is AM Unit 4, Lesson 7, and we're on exponential equations. And if you look on your guided notes, you see your steps there. The first one, it says rewrite using a common base. A common base means, now if you'll remember, exponential equations have a constant or a numerical base and a variable in the exponent. So your common base means that your base is going to be the same number. Now, when you have a common base, you're going to be able to use what we call the one-to-one property. And that says if b to the x is equal to b to the y, then x is equal to y. And you'll want to fill this part in on your guided notes there for number 3. Okay? All right. Now, what that's going to look like, this one-to-one property, it's telling you if your bases match, like right here in this equation, 3 matches 3, then you can use a one-to-one property. It's saying this exponent, x plus 2, must be equal to that one, which only makes sense, right? If your bases are the same and they're equal to each other, then your exponents must be the same. Once you get them in equation form, you're just going to be solving with your regular techniques. So, and that may be one place where we find a hiccup is when we're solving the equations, but I'm going to walk you through those as well. Okay, so let's just get started with some problems. And before we get started, I always use a chart like this that just lists, these are the exponents, 2, 3, 4, and 5. That's usually enough. And then these are the bases. So it just tells you 2 to the second power is 4, 2 to the third is 8. You know, 6 to the third power is 216, and you're going to see how that's going to come in handy. You also need to remember that a -1 exponent is going to flip your fraction. If it's 1 over 5 and you put it to the -1, that's 5 over 1. Okay, that's going to come in handy. So I just usually keep that posted somewhere I can see it. Okay. So let's jump in with number 1. Now, we already have common bases, so we're just going to apply the one-to-one property and let this say 2x minus 9 is equal to 7, linear equation. Now, that's all of the new stuff. This part is stuff you've been doing. So we would add 9 to each side. 2x is equal to 9 plus 7 is 16. Divide both sides by 2. And x is equal to 8. You can fill it in and check it, okay? So we have a winner there. Okay, let's look at number 2 here. It says e to the 4w minus 1 is equal to e to the 5 minus 2w. Don't let the e's make you uncomfortable. It just represents a number. So the bases are common. One-to-one property says that the exponent of the left side, 4w minus 1, is equal to this exponent. Now you just have a linear equation. So I'm going to add 2w to each side. 6w minus 1 is equal to 5. Then I'm going to add 1 to each side. 6w is equal to 6. Divide both sides by 6. And w is equal to 1. Okay, let's look at number 3. Here we go. Now this one's got a little level up to it because we have 2 bases over here. Now the bases are multiplied together, so what do you usually do when you multiply 2 bases that have exponents? If I multiplied x to the second times x to the third, well, what do you do with those 2 exponents? You add them, okay? So that's what we're going to do here. We're going to add c minus 1 and 3c plus 2. So what's that going to give us? c plus 3c is 4c. A minus 1 plus 2 is plus 1. All right, this one won't have to change. Now we have one common base on either side of the equation and exponents, so we can do the one-to-one property. So I'm going to put 4c plus 1 is equal to 7c plus 16. Now let's solve. I like to get rid of one of my variable terms. I'm going to get rid of the smaller one. So I'm going to subtract 4c from each side. 1 is equal to 3c plus 16. Now I'm going to subtract 16 from each side. So I have negative 15 is equal to 3c. Divide both sides by 3. And c is equal to negative 5. Okay, let's look at number 4. Now this time I have 2 bases on each side. So the first thing I'm going to do is add these two exponents, and that's going to give me 8 to the, all right, let's try to do the addition in our head. We've got that k to the second first. Now a k plus 2k is going to give me 3k, and then I have the minus 9. Okay, so you got a trinomial for an exponent. All right, over here, when I add these, I'm just going to have 4k plus 11. All right, now we have one single base on either side, and they match, they're common, so we can just set the exponents equal to each other. So that's going to be k to the second plus 3k minus 9 is equal to 4k plus 11. Now, that's all of the new stuff. So what we have here is a quadratic equation. That's from the past. I am going to walk you through it, but I do want you to know if you're good till here and then you start having problems, I'm going to put a link in the description for the lesson on factoring quadratics. So you might need to go back through that again. But anyway, there's different ways to factor or to solve quadratics. We're going to try the zero product property, and that means I need a 0 down here. So I'm going to subtract 4k from each side, and I'm going to subtract 11 from each side. That's going to give me a 0 down here. All right, over here I've got k squared. Now 3k minus 4k gives me a negative 1k, or a minus 1k. Negative 19 minus 11 gives me minus 20. To use the zero product property, we're going to factor this trinomial. No greatest common factor, no coefficient in front of the first term. We know it's going to be k and k. Since this is a minus, plus minus, I need a pair of numbers that multiply to give me negative 20 but add up to give me negative k. So that's minus 5 plus 4. Then you take k plus 4 equals 0 and k minus 5 equals 0. So k is equal to 5 and k is equal to negative 4. So your answer set is negative 4, positive 5. Okay, now let's move into the next section. Okay, in that first section, everything we had already had a common base. Well, now we're going to go next level. These do not have a common base. This is where your chart is fixing to come in handy. All right. So this one, we're not really going to need the chart because we can look at it. How could I rewrite, go to your lowest one first. Look at your lowest number, 9. How could I rewrite 81 as 9 with a 9 base to some power? Well, naturally, that's 9 squared. So we're not going to change the exponential over here. I'm just going to rewrite 81 as 9 squared. Now I have common base. 4y minus 26 is equal to 2. I'm ready to solve. Add 26 to each side. 4y is equal to 28. Divide both sides by 4. And y is equal to 7. Okay, let's look at number 6. 1 over 64 is equal to 4 to the 8 to the second minus 4. Obviously, we do not have common bases. In fact, this one is a fraction and this is a whole number. So the first thing I want to do is take the fraction and make it into a whole number. That's where remembering the exponent, the negative 1 exponent. So 64 to the negative 1 will flip that. Now at least I have whole numbers. Okay, look at your smallest number, which is a 4. And if you look on this chart, if you go to the 4 base and then we want to find 64, 4 to the third power is equal to 64. So I can rewrite that as 4 to the third to the negative 1. Now, why would I not write that as 8 to the second power? Well, because I don't have an 8 over here. You start off looking at the base you already have and you're trying to match that. All right, so technically I'm just going to rewrite this as 4 to the negative 3. Okay, equals 4 to the a squared minus 4. Now you're in the position where you have matching bases, so we can one-to-one property. Negative 3 is equal to a squared minus 4. Okay, let's solve it. We're going to add 4 to each side. So now I get a squared is equal to 1, and you can use your square root property. So a is equal to positive negative 1. Okay. Okay, number 7, we've got 2 to the n minus 9 is equal to 32 to the n plus 3. So we do not have common bases. All right, look at your smaller one, 2. Come over here to your chart. On the base column, start with 2 and go across that row until you find the number of the other base, 32. All right, you look up, 2 to the 5th power is equal to 32. So the first manipulation I'm going to do is to rewrite 32 as 2 to the 5th power. Now I have a power to a power. So what do you do in that case? If you'll remember, what do you do if you have x to the 2nd to the 3rd? This is when you multiply. So you are going to have to stay on your toes about when do you multiply and when do you add exponents. 2 bases, 2 exponents, you add. 1 base, 2 exponents, you multiply. All right, now I'm going to multiply 5 times m plus 3, so that's going to give me 5m plus 15. All right, now I have common bases. One-to-one property tells me to do m minus 9 is equal to 5m plus 15. Okay, so let us solve. Let's subtract m from each side. So I have negative 9 is equal to 4m plus 15. And then let's subtract 15 from each side. 4m is equal to negative 24. Now, divide both sides by 4, and m is equal to negative 6. Okay, now number 8, we have 1/12 to the 4x plus 3 times 12 to the x squared equals 12 to the 2x plus 13. So, how am I going to change this so that it matches these two? Using that negative 1 property. So I'm going to have 1 over 12. Actually, I'm going to have 12 to the negative 1 to the 4x plus 3 times 12 to the x squared is equal to 12 to the 2x plus 13. When I distribute the minus 1 there, now I have 12 to the negative 4x minus 3 times 12 to the x squared is equal to 12 to the 2x plus 13. Okay? We're multiplying bases here, so we need to add the exponents. So when I put x squared, and I'm just going to go ahead and one-to-one property it with this so that because I'm running out of space. So I'm going to have x squared plus this, which will be x squared minus 4x minus 3 is equal to 2x plus 13. All right, quadratic equation. So let me get a 0 down here by subtracting 2x and 13 from each side. So I'm going to subtract 2x and 13 here. So now I have x squared minus 6x minus 16. And then how do we factor this now? Zero product property. So this is going to factor into x plus and x minus. We want a pair of numbers that multiply to give you negative 16 but add up to give you negative 6, so that's 8 and 2. Zero product property is going to give you x is equal to negative 2 and x is equal to 8. There you go. Okay, let's look at number 9. I've got 343 to the 2n minus 4 is equal to 1 over 49 to the n plus 4. Now just do one step at a time. The first step is to get common bases, so let's worry about that. I see a fraction here, so the first thing, let me raise that to a negative 1 to get rid of the fraction. Now I'm not going to change this side right now, so just leave it like it is. All right, now what's going to happen when I raise this to the negative 1? Well, I have to multiply negative 1 times n plus 4, so what am I going to have? 49 to the negative n minus 4. Okay? So now at least we have whole number bases. Now this is where your chart comes in handy. You see your two bases, 49 and 343. Neither one of them is, a lowest base. So look on your chart and see, is there any base that has both of these numbers? All right. And when you come right here, you see that 7 squared is 49 and 7 to the third power is 343. So that's going to be your link to a common base. I'm going to rewrite 343 as 7 to the third power to the 2n minus 4. I'm going to rewrite 49 as 7 to the second power to the minus n minus 4. Okay, so we're ready for one-to-one property, and we do need to multiply these exponents. So let's do that all in one step. If I multiply 3 times 2n minus 4, I'm going to get 6n minus 12. If I multiply this 2 times negative n minus 4, I'm going to get negative 2n minus 8. And we're good to go now. We're going to add 2n to each side. So I have 8n minus 12 is equal to negative 8. And then I can add 12 to each side. So now I have 8n is equal to 4. Divide both sides by 8. And n is equal to 4/8, which is 1/2. Okay, let's look at number 10. And I actually had to go make my chart a little bit larger because this one needed more numbers, but that's okay. That's what you have to do. If you can't find one of the numbers on your chart, you're just going to have to expand a little bit. So what we're doing here, we have two bases, 8 and 128. Now they're not going to have 128 is not going to be an exponential of 8. So what we're going to do is we're going to look for a row that has both of these. And when you go across the 2 row, you see there's an 8 and a 128. So 8 is equal to 2 to the third, and 128 is equal to 2 to the 7th. Now we have the exponent already on the outside, so we can't lose those two things. Okay? Now we're going to multiply these two together and those together, and then we're going to be ready for your one-to-one property. So I'm going to skip that step, okay? As I distribute the 3 and the 7, I'm going to get rid of the base. I'm going to go ahead and switch to the one-to-one. So 3 times 2 is 6 minus 3v equals 7v plus 21. Now we're just ready to solve. Let's add 3v to each side. So I have 6 is equal to 10v plus 21. Subtract 21 from each side. You get negative 15. Divide both sides by 10. V is equal to negative 15 over 10, which reduces down to 3 over 2. Okay, number 11, 9 to the negative p is equal to 243 to the 2p plus 6. Once again, we're going to look for these two bases and see if we can find them on the same row. So I look on the 3 row and I see there is a 9 and a 243. So that's what's going to let me make common bases. I can rewrite 9 as 3 to the second power to the negative p. And then I can rewrite 243 as 3 to the 5th power to the 2p plus 6. Okay, we have common bases, so we can go ahead and go to our one-to-one property. We are going to have to multiply our exponents together when we bring them down. So 2 times negative p is negative 2p. 5 times 2p is 10p, and 5 times 6 is 30. And now we're just ready to solve. Let's subtract 10p from each side to move it over here. Negative 2 and negative 10 is negative 12p equals 30. Divide both sides by negative 12, and p is equal to, 6 will go into 30 and 12, so that'll be negative 5 halves. Okay, number 12. Now, both of these are fractions. And it really doesn't matter, you know, if they're both fractions, we can leave them we can leave the number in the denominator, because our goal is just to get a matching base. It doesn't have to be a whole number. All right, so 64 is an exponential of 4. 4, if you look on your chart, 64 is 4 to the third power. So we're not going to change 1/4. It's going to stay the same. This one we're going to rewrite as 4 to the 1/4 to the third power, but we're going to multiply it times that 2x squared minus 5. Okay? Now that we have matching bases, we can use our one-to-one property, and let's just go ahead and say, all right, 2x squared minus 6 is equal to, now we have to distribute this, so we're going to have 6x squared minus 15. Okay, now we're just solving whatever we have to do to solve this quadratic. That's a previous skill. So I would subtract 2x squared from each side. So this is going to give me negative 6 is equal to 4x squared minus 15. Add 15 to each side. I get 4x squared is equal to positive 9. Divide both sides by 4, and let me come up here. Now what you have is 9/4 is equal to x squared. Perfect situation for the square root property on this one. So you take the square root of each side, and x is equal to plus or minus. Remember, if you insert the square root, you have to use a plus or minus. And the square root of 9 is 3. The square root of 4 is 2. So there you go. Okay, number 13, we've got 36 to the 2r times 1 over 36 equals 216. All right, so what we need here, we're going to look for a row that has 36 and 216. So let's, right here, your row 6, 6 to the second power is 36, and 6 to the third power is 216. So let's use that to convert. So this first one, we're going to change that to 6 squared to the 2r times. Now this one is, yes, it's going to be 6 squared, but in order to flip it, we're going to make that 6 to the negative 2. And then 216 is going to be 6 to the third. All right, 2 times 2r, so this is going to be 6 to the 4r times 6 to the negative 2 equals 6 to the third. Now, when you have two bases multiplied together, what do you do to exponents? You add. So 4r plus negative 2 is just going to be minus 2 equals 3. And now we're just solving. Let's add 2 to each side. So 4r is equal to 5. Divide both sides by 4. And you get r is equal to 5/4. Okay, number 14 is 25 to the a times 625 to the a plus 3 over equals 1 over 25. All right, so let's start adjusting. First, let's figure out what do we want to make a common base. I'm going to choose 5 because both of these are on the row 5. But when I get through, I'll tell you another way that you could have done it. You've probably already seen it, but I'm going to go ahead and go with 5. Now, 25 is 5 squared and then to the a power. 625 is 5 to the 4th, and this is times 5 to the 4th to the a plus 3. All right, now this 25 is 5 squared, but I need it to go up, so I'm going to make that negative 2. Okay, so now we have the same bases, so we can go ahead and go to our one-to-one property. First, we're going to multiply 2 times a. That's 2a. Now remember, we're going to add exponents. When you multiply bases, you add exponents. So now 4 times a is 4a, and 4 times 3 is 12 equals negative 2. So we have 6a plus 12 is negative 2. Subtract 12 from each side. 6a is equal to negative 14. Divide both sides by 6. A is equal to negative 7/2. And like I said, I tell you, 625 is actually 25 squared. So you could have done it that way and you would have had smaller numbers, you wouldn't have had to reduce. Either way, as long as you use your properties and get a common base, you can still use that 1-to-1. Okay, number 15, we have a mix of fractions, so we know we're going to involve some negative exponents there, but we look at the three numbers first, 16, 64, and 32. Is there a row that contains all three of those? And yes, the row with the base of 2. So let's look at this. 16 is 2 to the 4th power, but I know I'm going to need to flip it. So I'm going to go ahead and write that as 2 to the negative 4 to the x plus 7. All right. 64 can be written as 2 to the 6th power. So I've got 2 to the 6th to the x plus 5. Then 32 can be written as 2 to the 5th power, and since I need to flip it, I'm going to make that 2 to the negative 5 to the 4th. Okay, now we have common bases, so we're ready for our 1-to-1. We just need to keep our head in the game. We're going to distribute this, and those two things are going to be added when I get down here. So negative 4 times x is negative 4x. Negative 4 times 7 is negative 28. 6 times x is 6x, and 6 times 5 is 30. And over here, negative 5 times 4 is negative 20. Okay, let's combine. Negative 4 plus 6 is going to give me 2x, and negative 28 plus 30 is going to give me positive 2, equals negative 20. Subtract 2 from each side, and I get 2x is equal to negative 22. Divide both sides by 2, and we get x is equal to negative 11. Okay, number 16. Now we look at our three bases here. We see we've got some fractions, so we're going to have to use some negative exponents. But let's just look at the numbers first. 8, 64, and 512. I come over here to my chart. Is there a row that has all three of those on it? Well, yes, the row where it's base 8 has all three. So let's convert all of those to a number that has 8 for a base. All right, 512 is 8 to the 3rd power, so I can rewrite that as 8 to the 3rd to the y squared power. All right, 64 naturally is 8 squared, but I need to flip it. So I'm going to make that 8 to the negative 2 to the 3y times. All right, now this one I don't need an exponent other than 1 to make it flip. So this is going to become 8 to the negative 1, 5y squared, one step at the time. Now we're going to come back and we're going to multiply our exponents, and we're going to remember that since I have two bases here, we're going to add those exponents once they're multiplied. All right, 3 times y squared is 3y squared. Negative 2 times 3y is negative 6y. And negative 1 times 5y squared is minus 5y squared. Okay, now what can we do? I have a y squared and a y squared, so let's add 5y squared to each side to combine terms. So now I have 8y squared is equal to negative 6y. So that I can use my zero product property, I'm gonna get a 0 here by adding 6y to each side. So now I have 8y squared. Let me come up here. I have 8y squared plus 6y, I know that looks like a 4, is equal to 0. All right, let's factor. Greatest common factor here is 2y. So that's going to give me 4y plus 3. Now I'm using zero product property, so I'm going to put 2y is equal to 0 and 4y plus 3 is equal to 0. Divide both sides by 2, y is 0, and here subtract 3 from each side. 4y is equal to negative 3. Divide both sides by 4. So y is negative 3/4. So my answers are -3/4 and 0. Great job, y'all. Great job.